sini.
Okey, atuk ada kelas. Keluar sekejap. Kacau.
Nanti lampu bombong. Tengok video lama ni.
Tak, atuk ada kelas ni. Jangan kacau.
Itu kamera aja.
Ya, patutnya. Dah. Jangan kacau. Okey, thank you. Assalamualaikum warahmatullahi taala wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Alhamdulillah. Everybody fine? Anybody here from Sabah? No. Yes. Right now, cases in Sabah is getting very high. So anybody from Sabah, you should take care of yourself. Okay, now today is our, actually if you look at the average of the course, today is our second class, on Wednesday. And today will be our continuation of the chapter number 1 that is on the linear function. Now, before we start, do you have any question regarding the homework question that I give you last class? These are the questions that I give you, right? These numbers here on 1.3. Any question with these problems? Or any problem with the question? Okay? All right. So today, we are going to continue. What we will do today, we want to find, or not want to find, we want to discuss a little bit about the slope. The slope and then the intercept. So if you look at the slope-intercept form, this is the M, and this is the y-intercept, which is B. And after that, after we define the concept of slope, what we'll do here, we will determine the function. Okay, we want to determine the function, the linear function, given some information. Given some information, we are going backward. Earlier, you're given you're given the function, you draw the graph, you find the line. So here it's the other way around. You are given some information, you want to find the equation of the function. So that is our main discussion today. And then number 2, secondly, I would like to discuss about more detail, okay, on the slope M and also on the intercept. So intercept here, both the B, which is the y-intercept, also the x-intercept. So that will be our focus today. And if we have time, we're going to look at a system of linear equations. Okay, linear functions. More generally, linear equation. So that is our plan today. Now let's go and define what is the slope. Okay, the slope is M. Okay, I will write down here. Number 1, slope. Now slope is M. Now what do you know about slope? from your earlier, mathematics. What do you understand about the slope? What does the slope tell you about the line?
Downward.
It can be downward sloping, it can be upward sloping. But what does it tell you? Okay, the slope gives you a measure of the steepness of the line. Okay, steepness of the line. When I say the line here, I mean the straight line, which is the function. For example, if you recall, okay, you have x, y here, and then you got one line, okay, call it y1. And then you have another line, call it y2. So if you compare y1 and y2, which one is steeper, y1 or y2? You look at it from the left to the right, all right? As x increases, that means as x go from the left, the lowest negative up to the highest positive, what can you say about the curve here, the two curves, the two lines? Which one is more steeper? Which one is steeper? The first line or the second line?
Y1.
First line.
Y1.
Okay, so
Y1.
the first line is steeper. So M tell you about the steepness of the line. So M is a measure, okay? M is a measure of the steepness of the line, and that is, of course, the slope. So the slope tell you how steep is the line, okay? As we go from the left to the right, all right? So that is M, or the slope. Now, how do you get the slope? It's measured by the following. M, okay, is equal to, how do you measure the steepness? Is equal to the change in y divided by a change in x.
Atau ni cerita ke budak?
Pergi sana. Pergi ke ibu lah.
Aku kenapa ada masuk?
Pergi ke ibu. I'm sorry, because my granddaughter is here. Okay, if you go back to if I draw the graph, right? And the slope is defined by delta y over delta x. Now delta y is the change in y. Delta x is a change in x. So it's the change of y divided by a change in x. So it's a ratio, okay? The ratio of the change. Now, what is a change? A change is equal to what? It's equal to the following. If I can draw you the line again here, okay? Let's say here you got y equal to mx plus b. The change is equal to difference between two values. So here we need to consider 2 points, call it a point A, and then another point, call it B. And point A is x1, y1. And let's say we have point B, x2, y2. So given 2 points, okay, so given the 2 points, then the slope is defined by the change in y and the change in x. So let's consider 2 points. Okay, 2 points, which is A, x1, y1, and then B, x2, y2. So what is the change in y? The change in y is the difference between two values of y. So therefore, it will be equal to y2 minus y1 divided by x2 minus x1. So y2 minus y1 is the difference. So the difference is change in y. X2 minus x1 is the difference in x, that is the change in x. So the change in y is the difference between y2 minus y1. So if we go back to the graph, that will give you that distance. So that is delta y. And the difference between x2 and x1, we call it delta x, the change in x. So the ratio, okay? The ratio of delta y to delta x will give you the slope, all right? So the ratio of the change is the slope. Okay, any question, any comment? Yeah.
No, sir.
Okay, I heard somebody was saying something. Okay, now let's go on. So the m is equal to delta y over delta x. And that is a value, okay? That is a value. And m is a value, is a number. So that will be obtained by the difference between the values, the two values of y and the two values x. So let's say, okay, let's say just for example, the value of x1, y1, say it is 2 and 3. And the value x2, y2, say here 10, 12. So the slope, okay, so the slope here is equal to what? It's equal to y2 minus y1, which I have here, all right? X2 minus x1, and that will be equal to 12 minus 3, which is y2 minus y1, divided by 10 minus 2, which is 8, which is, I write down 10 minus 2 before we give the answer. 10 minus 2. So that will be equal to, I go here, that will be equal to berapa? 12 minus 3, that will be 9, right?
9 over 8.
9 over
9 over
8.
8.
Okay. 9 over 8 will be equal to 1 point. Anybody has a calculator?
1.125.
1.125.
Yeah.
Okay, 1.125. So that is the slope. That is the ratio between the change in y and the change in x, right? Okay, so that is the slope. Now, how do you read that? So to read that, the ratio of the difference, we say the following. Since the ratio of the change, all right? And then you get a number. So we say the following, m is the change in y. Okay, m is the slope in y for a unit change in x. Or, okay, since it's a straight line, you can also say m is the change in y per, okay, per unit change in x. Because when you divide the ratio of two numbers, so that is simply what? Simply change per unit. So that will be just change in y, okay? Change in y per unit change in x, which I have. So it's the m. So if you look at the book says m is the rate of change. Okay, the rate of change, what do we mean? It's the change of y per unit change in x. Okay, that's the rate of change. That is the change in y per unit change in x. Okay, all right. Now we are going to discuss this in a little bit more detail later on. Okay, but now I just want to define the slope because we need this formula in order for us to get to discuss, how to get the function given some information. Now, when you have a linear function, a straight line, the slope, all right, the slope is the same everywhere. The slope is a constant. So if you take the 2 points, A, B, and you take another point, A, C, okay, say you have another point here, C, and you take the slope between A and C, you will be you will get the same value, same value. So when we say for a straight line or linear function, m is a constant, okay? So m constant, meaning that the slope is the same everywhere, okay? If you take any 2 points, you will get the same m, okay? That is for straight line. For straight line or linear function. So for a linear function, the slope is a constant. It's the same everywhere, okay? You take any 2 points, you will get the same value of m, all right? Okay. Now, what about B? We will look at B. B is the y-intercept, okay? The y-intercept, that means it's the point or it's the value of y, when x is equal to 0. All right, so that is B, y-intercept. And the point is called, or you write for point y, 0y. There will be 0b. Okay, so in this case, the intercept is B, so the point is 0b. So if you look at back the graph, this is the point, okay? The intercept is here. That is intercept, that's B, okay, that's B. So that point is 0b, so that is the y-intercept. So I will talk more detail about this because we also need to look at the x-intercept. So we will do it afterwards, all right? The x-intercept, the x-intercept, oh yeah, I think we will just describe the x-intercept. Now the x-intercept is what? Is the value of x. I think I just write it down. The value of x for y equal to 0. So it is not straightforward, all right? It's not very straightforward. You have to use the function, okay, y equal to mx plus b, and then you will substitute y equal to 0, then what you get will be 0 equal to mx plus b. So what is x? X equal to negative b over m. So the x-intercept will be negative b over m, 0. So you have to do, an extra work. Just substitute the y equal to 0 into the function, and then you get the x-intercept. Now the x-intercept, if I go back to the graph, would be you have to extend the line. Okay, I think it will be somewhere there. So you just label that point negative b over m, 0. Okay, all right. Okay, any question about this? Okay, now I go back to the slope. Okay, I go back to the slope. I draw here a line which is m, or of course constant, but m is positive. Okay, now m is, because you have a line which is going downward like that. Okay, so for the line that is going downward from the left, that means as x increases from the left, you have the line going downward. It's like you are running down the hill. In this case here, the slope is negative. So for the line that goes downward, the slope will be negative. Of course, the formula will be the same, okay? But you will get a negative value of m. Okay? Okay. And of course, you know, you may have also cases where the slope of the line equal to 0, and the slope of the line is undefined. Okay, so how do you have this? So that one, you read the book. Okay, you read 1.3 or 1.4. Okay, now let's go back to our next discussion. So what you want to do here is number 2. You want to have, or you want to find the equation of the function. Okay. Given some information, you want to find the equation of the function. First, you are given 2 points. Okay, given 2 points, then what is the, how can you find the function? Now the method here is simple. We're going to make use of the slope formula. All right. There are 2 ways here. Either number 1, you use the slope formula. And number 2, we substitute into the function, the slope intercept form. Okay. So let us do number 1 first. I think number 1 is most straightforward. Given 2 points, let us do by an example. Suppose you are given 2 points on the linear equation or linear function. Suppose you get 5, 5, 5, 5, 5, 4. Okay. You got 1, 5, 4, and then the other one is 20, 40. All right. Now find the equation of the straight line or the function. So what you do here, suppose you are using the method number 2, substitute into the slope intercept form of the function. So what you do first is that you let the 2 points be x1, y1, and x2, y2. So let's say you let the first point 5, 4 is x1 and y1, and then x2, y2 will be the second point, 20, 40. Okay, so what we do here, first, all right, first you find m. Because we know m is what? M is the delta y over delta x, and that is equal to y2 minus y1 divided by x2 minus x1. And then we already have the 2 points, x2, y2 is 20, 40, x1, y1 is 4. So put in the numbers. So what do I get? I get 40 minus 4, okay, which is y2 minus y1, divided by 20 minus 5, which is x2 minus x1. So that will be equal to 36 divided by 15. So what is the value? The value is 2 point something now. 2.4. 36 divided by 15, 2.4. So the slope is 2.4. Now, given that you know already the slope, you find b. So now, okay, you got the function. Okay, am I going too fast or you can catch? I mean, you can follow me.
Can follow.
If I go too fast, let me know.
I can follow that.
Okay, so I would, I want you to understand. That means I want you to write. Okay, write your notes, good notes, because this is the concept. So now you know the value of m. So therefore, now y is equal to 2.4 x plus b from the given m that you already computed. What you need to do in the second is you need to find b. Okay? Now, how do you find b? We have to substitute one value. Okay? Either x1 or either first point, x1, y1, or x2, y2. So you have to substitute one, x1, y1, or x2, y2. Which one? It's up to you. Okay? You make your choice. So to make our life easier, you choose x1, y1. Okay? So because it's smaller number, so we substitute x1, y1 equal to 5, 4 into y. So that you can find the value of b. Okay? So x1, y1, 2, 5, 4. Okay. X1, y1, 5, 4. So what I get will be equal to y, which is y1. Then will be 5 equal to 2.4 times x1, which is 4, plus b. So you get b. B equal to 5 minus 2.4 times 4, that would be 9.6. Is that right? 9.6. That would be 4.4. 9.6 minus 5, 4.6. Negative 4.6. Is that right?
Yes.
Okay. So that is the value of b. Therefore, our function y equal to 2.4x minus 4.6. So the y-intercept is 4.6. The slope is 2.4. So that is our equation.
Sir,
Yes.
But the y is
why is
you
why
switch
for
x and y.
Huh?
I think you
the
switch x and y.
Oh, yeah.
The y
Yeah.
is
Y
4.
is 4. Okay, correct. So thank you. Actually, the value of the y, I got it upside down. Okay, thank you. So you put the value of y1, which is equal to 4. So everything here would be different. So that would be 4, 5. And that would be 4 minus 2.4 times 1, that would be 12. 12. Yeah. So 4 minus 12, that would be negative. So therefore, our curve or the equation of the linear line or linear function will be 2.4x minus 8. So that is the all right. Now, if you go by the other method, okay, if you go by the other method, what you do will be the following. The other method, you need an extra point. I think we just use this method. Okay, I think we just use this method. We don't have to use the other method because we need to cover quite a number of things. Okay, so that is the equation. So I'll give you another example. Suppose you are given 2 points, 20, 20, 20, negative 5, 20, negative 5, and then the other point, say, negative 5, 35, 30, 30, 35. Okay. This one, I think we give you nice number. So here, given these 2 points, okay, given these 2 points, I want you to find the linear function. Okay, wait now. Use the method that we just described here. First, you find m, okay, by the slope formula. After that, you get to find that b.
Kok yang menjaga kereta kan?
Okay, we got the slope. What is the value of m? Anybody got it?
Negative 1.6.
Negative
1.6.
Apa?
Negative 1.6.
Negative 1.6. Everybody got negative 1.6?
Yes.
Okay, good. Now you got the slope m. Okay, just the you take the second point as x2 y2. Okay, and then the first point you say x1 y1. Take the difference. All right, that you get m, which is berapa tadi? M berapa? Negative?
Negative
1.6. So now, okay, you choose one point, either the first point or the second point, doesn't matter. You'll get the same thing. Find B. Okay, go ahead. What do you get for the B?
27.
Berapa?
27.
37.
27.
27.
97. Okay.
27.
Huh? 27.
27.
Doctor.
27.
27. Okay. 27. So B is 27. And what you get will be, get the function, okay, y equal to negative 1.6 plus 27. So that is the function. So in this case here, you get the value of m negative. So negative slope is negative, that means the line will go downward. So for this one, I want you to draw the graph. Okay, we have been drawing some functions, okay, some graph mostly going upward. So this one will be going downward, negative slope. Okay, next. We are given the slope, and then we are given 1 point. Okay, so how do you find the function? So you are given 2 points. We already did that. And then number 2, you are given the slope. Okay, we know the slope. Okay, given m, we know m. And then you are given a point. So in other words, m is given, say example here. Okay, m is equal to 3.5. And then you are given 1 point, say, 10, 25. Okay, so that is 1 point on the line. and you are given the slope. So how do you find the equation? So here, again, by substitute. Number one, okay, you substitute what you know. First, you substitute m equal to 3.5 into y. So what you got will be y equal to 3.5 x plus b. So our beginning point is, of course, y equal to mx plus b lah. Okay, so we start from there, just from the set form. And then first you substitute the m, okay, which is 3.5, and then you need to find b. So to find b, again here, we substitute that point. Okay, that point, call it x1, y1, equal to 10, 25 into, again, y. All right, so what you got will be 25 equal to the slope 3.5 multiplied by x1, which is 10, plus b. So b is equal to 25 minus 35. 3.5 times 10, there are 35, so negative 10. Therefore, our function will be equal to y 3.5x plus, no, plus, minus 10. Okay, so that is our function. Now, third case will be very straightforward. You are given the slope, you are given the intercept. Okay, so simply do it by direct substitution. So the third option, will be very, very straightforward. You will get the equation right away. So number 3, okay. Number 3, you are given m, and also you're given the b. Okay, so will be straightforward. All right, will be direct substitution. Direct substitution. So say, example, m is equal to 10.4, and then b equal to 76. So simply substitute, okay, into y equal to mx plus b. What do we have? We have y equal to 10.4x plus 76. So this case here very straightforward. All right. So what we are doing, okay, here will be basically 1.3. Okay, 1.3. I would like you to look at the book. Go to 1.3 in the textbook. We already defined the slope, okay, which is given in 1.3, which is the delta y over delta x. And if you look at the page 78, right, so basically our discussion here 1.3, you will see the negative slope, positive slope, and perpendicular, horizontal. So I would like you to read just one part of the book. I want you to read this part here, the line on parallel, okay, parallel lines and perpendicular. All right, perpendicular lines, and see what are the characteristics or what are the relationship between the slope, okay, between the slopes of the two lines, such that they are perpendicular or they are parallel. So that will be just extra reading for you. If I go by my book, it's on page 78 to 79. If you have another edition, probably a different page. So that thing I would like you to read. And There's another thing that I want you to see. Is it 1.2 or 1.3? No, you look at the book. Yeah, I want you to see the following. Go to page 82. Again here, 1.3, page 82. Here, you have a different form of linear equations. You see here, forms of linear equations. Okay, you have the book. Can you see that forms of linear equation? I want you to look at the forms, all right? Number one, you have horizontal line, okay? Horizontal, what is the equation? Y equal to B, okay? Example, say Y equal to 5. So how does the graph of that line look like? It's horizontal, okay? So in other words, if you draw the graph, 0, 5, this is 5, y equal to 5, that is y equal to 5, okay? But that y equal to 5 corresponds to 0, x equal to 0. But for every x, okay, for every x, y is equal to 5. So what does it mean here? For every value of x, y is the same value, 5. So how does the curve look like? The line will be horizontal. So that is y equal to 5. Okay, my question, is this a function? Is this a function? Does it satisfy definition of a function?
No.
No.
No. Anybody? Go check again. You do the mapping, you know, you do the mapping. Every x, okay, maps to 5. Okay,
Yes.
that is horizontal. Now, I want you to think about it. You look at vertical line. Okay, vertical line, x equal to c. Okay, in the book here say x equal to a. Example, x equal to 10. All right. So x equal to 10, you got 5 here, you got 10 here. For every value of y, x is 10. That means x equal to 10 will map to every value of y. So the line will be vertical. So that is x equal to 10. Now, is this a function?
No.
No.
Okay,
No.
vertical line is not a function. Okay, vertical line is not a function. Why? Because the value x, which is 10, maps to every value of y. Okay, so that does not satisfy definition of a function. Now, what about the horizontal line? Y equal to constant.
Yes, it is a
Every
function.
x maps to 5. Okay, does it satisfy definition of a function?
Yes.
Yes. Okay, every x maps to y is equal to 5, and that is the only value. Okay, that is the only value of y. So each x maps to only one value of y, which is 5. It can be the same, it can be different. So y equal to b is a function. But x equal to c is not a function. So make sure we know that, all right? You have to relate back to the definition of a function. So the other form will be just a different form for the general, the slope intercept form and the general form of the function. So that will be no problem. Okay, I would like you to do some question. I think I give you some question already. So let's go back to last class. I'll give you question again, 17, 18, 19. That means I want you to draw the function, is that right? Okay.
Yes.
And now I
Yes.
will let you to do a few more questions. So 1.3, I will add here. Okay, I will add the questions here. So that dia ada sekali 1.3 tu, tak ada lah nyamuk. Okay, so some other questions on 1.3. Saya dah tanda dah tadi. I want to make sure I give you the right question. Yeah, 1.3. 1.3, I want to give you question 2 and 4. Okay, 2, 4. I want you to find the intercept and graph the function. You know that is the question as per the book. I would like you also to write in the slope-intercept form. In other words, you want to find the slope-intercept form. So in that way, you will get the slope, you get the intercept. So the question asks you only to find intercept. I will like you also to find the slope, okay? And then draw the graph. If you want to draw the graph, you go ahead, draw it. Otherwise, you don't have to draw. And then question number 6 to number 8. Or maybe number 9. Okay, this is what we learned today, all right? I would like you to find, the question in the book asks you to find the slope, okay? But you do the extra work. You find the equation of the linear function, okay? So you find the equation, not just the slope, you need to find the intercept and then get the equation. So that will be 6 to 9. And then 31 to 34. 31 to 34, you are given the slope. Okay, so 31 to 34, you are given the slope and a point. So again here, I want you to find the equation. And of course, if you want to do more question, you can do, 35 to 38. You can also do that. If you want to do more, if you don't, then I think the one that I give you is already sufficient. Okay. So we are done with 1.3. Okay, any question? All right. Now I would like to look at more detail into the slope before we move on. Yeah, we need to look at more detail in the slope and the intercept. Okay. The slope, as we know, it can be positive, it can be negative, and it can be 0, okay? And it can be undefined. Okay. Now we go back to the definition of the slope. M is equal to delta y over delta x, which is the change in y, right? M is the change in y per unit change in x. Okay. So if you recall, M is, I write down somewhere earlier, M is the change in slope, okay, which is M, is the change in y per unit change in x. So example, let's say we go back to the example that we have earlier. Berapa tadi, mana dia? Equation kita dapat ni. Okay, this one. All right, y equal to 10.4 x plus 76. So what is the slope? The slope is 10.4. So now, how do you describe 10.4? So example, m is equal to 10.4. So I want you to describe that value in terms of the definition that I just stated. All right, how do you describe it? M, okay, the slope m is the change in y per unit change in x. Anybody? Right? Tak ada orang ke? Are you still there? Describe
Yes,
the
sir.
slope, okay, which is 10.4 in terms of the definition that I just described. Two point four. Okay, anybody? Okay, Ibrahim, are you here? Ibrahim?
Yes, sir.
Okay, try.
The change in y for a unit change in x is 10.4.
Oh, that's correct. Is that right? Yeah, so the change in y per unit change in x is 10.4. All right, or you can say the change in y is 10.4 per unit change in x, or for a unit change in x, or you can say as per Ibrahim said. All right, now I'll give you a second value. Suppose the value of m is equal to negative 5.1. All right, how do you say that? How do you describe it? Sophia, Alicia. Sophia, are you here? Izati Zainal.
Yes, sir.
Okay, try.
The change in y is negative 5.1 per unit change in x.
So the change in y, okay, or you can say, as per Ibrahim said, the change in y per unit change in x is negative 0.1. Or you can say the change in y is negative 5.1 per unit change in x. Okay, but the problem is here, if you look at the value, all right, the value of the x, for first case here, you got positive, the second case, you get negative. So positive or negative, you still have change, okay? So now we want to be more specific so that we can describe more accurately whether it is positive or it is negative. So we can say, we can do this. Okay, the change, all right, change can be what? Number one, positive. Number two, negative. So you got the value of m can be bigger than 0, which is positive, m less than 0. All right. Now you go back to the definition of the function, the slope, delta y over delta x. Now, when you look at the change, or here in this case here, m is bigger than 0. Now, if m bigger than 0, you want to be more specific about the change. So you look at the delta x, all right? Delta x, the change in x, for positive value of x, or for positive value of m, then what can you say about the change in x? Is it going up or going down? Is it increase or decrease? So the change, okay, can be increased. Now, if delta x increase, you know the slope is positive. Then what about delta y? In other words, when we say delta x increase, that is positive increase. Okay, the value of delta x is positive. That means y2 be x2 bigger than x1, say equal to 2. Okay, that is an increase. So increase means positive change. Now, if m is bigger than 0, what about delta y?
Increase.
Delta y will be increased. Okay, so delta y will also be positive. That's one. Second situation, if the delta x show a decrease, okay, show a decrease, that means what? That means a negative change. Negative change, that one. Okay, maybe delta x decreases by 4. Now, for the slope to be positive, what about delta y?
It must be decreasing also.
It must also decrease, okay? Because you have a negative and negative, that becomes positive. All right? So given the change, whether the slope is positive or negative, we can describe it in more accurate manner, okay? In terms of the positive change, which is increase, or negative change, which is decrease. Okay, you understand? Anybody need another explanation? Do you understand that or you don't? Okay, so now go back to our example. We are going to go back to this one. Now, here we are talking about very general concept, change. I want you to modify it, all right? To be more specific for the slope here, which is positive. So let's do that. Okay, anybody who wants to try to describe it in the more specific manner to reflect the positive change, which is increase and increase, or yeah, we do the positive side, okay? Positive and positive. So anybody wants to try? Anybody? Oh, no, it doesn't matter. You got it wrong, that's fine. Okay. Sharifah? Sharifah? Ada ke tak ada ni? Marista? Diam lah. Okay, Ainul Yasmin. Ainul Yasmin ada ke tak ada? Ini Muhammad apa ni? Muhammad apa ni? Muhammad Talib apa? Okay, Muhammad Ta, as per the screen there. Terus apa ke? Anybody wants to try? Go ahead. Okay, Arif Afifi.
Yes, sir.
Okay, go ahead.
Wait.
We do this, all right? When the slope is positive, all right? Slope positive, if we say the delta x, okay? That means delta x positive means delta x will increase, okay? X increase. Now what about y? Y will also increase, Okay, so when you have m bigger than 0, x increased by 1 unit, y will also increase. So therefore, if you go back to the example here, how can you say that? Siapa nama tadi? Azizi. Okay.
Sir.
Okay. Finish it up. Just try it.
The change in y per unit increase. Well, the change in x is increased to 8.
Okay. So you have m bigger than 0. So you got x increase. That means y will increase. All right. So what you do here is what he said was correct. It's just the phrase. Okay. The phrase you have to refine it. Okay, can anybody rephrase what he was saying in a better way?
Sir, I would like to try, sir.
Okay, go ahead. Siapa nama ni?
Ridwan.
Okay, Ridwan, go ahead.
The change in y over x is increasing positively at 10.4.
Okay, that's good. I want you to do it the way that I wrote there. What you say was correct, okay?
Okay.
But I want you to do it in the form that I have here on the screen.
Do you understand, sir?
you put it in the way, m is positive, right? M positive means if x increases, y will also increase. So the change is increased. So what do you do here? If x increased by 1 unit, then what happened to y?
Increase 1 unit too?
The y will increase, but not by 1 unit. By how much? How many units?
10.4.
10.4. Okay. So here, if the slope is positive, as we know, if x increases, y will also increase. For the m to be positive, is that right? So instead of saying change, okay, you put in increase. So both increase. So we say the following: the x will increase by 1 unit, y will also increase. Okay, but the increase in y is by the value m. So we say the increase in y is 10.4 per unit increase in x. So I think what you said was correct. We put the units here. Okay, it's 10.4 units, whatever the units are. Okay, any question about this? So now the change, okay, the change for the slope positive, if the x increase, the y will also increase. If the x decrease, what happened to the y?
Decrease.
The y will also decrease for the sign to be positive. Is that right? So by the same token, if I want to say, okay, if you want to say in terms of decrease, all right, so here I say a unit decrease in x. Then what about the y?
Decrease.
Decrease. So we say, okay, which is perfectly correct. The decrease in y is 10.4 units per unit decrease in x. So now it's decreased. Okay, that means it's going downward. Both decrease, the slope is positive. But okay, having said that, normally we'll say the increase lah. All right, we'll say increase and increase. But we should also understand it can be also a decrease. Okay. Okay. So here we are going to be more specific in terms of the changes for the specific type of value of x. Okay, I'll give you another example. We do another example. say M is equal to 2.1. All right. So that is positive. Now, anybody who wants to try this? We use increase, okay? That means the X will increase by 1 unit. Then, what about Y?
Sorry.
Okay, go ahead.
When the increase in X is 2.1 unit,
it's not the increase in X by 2.1 unit. 2.1 unit is the increase in what? In which variable?
Y.
Y.
Y. Okay.
That's why.
So the increase in Y is 2.1 unit
Y is
per
2.1
unit increase in X. Now you remember this. Any number, okay, 2.1 or whatever, actually is divided by 1. Okay. This value that you got negative here, 10.4. And 10.4, you don't write over 1, no, but it is divided by 1. So it's 1 unit increase in X. Okay? Because you already take the average.
Yeah.
So for the second example, tadi mana dia? Ni ada. For 2.1, meaning what? For a unit increase in X, okay, also like you just use another phrase. For a unit increase in X, what about Y? Y increases by the value of the slope, increases by how much?
2.1.
Or Y increases by 2.1 unit per unit increase in X. So that indicate the positive slope. All right, any question? Okay, second, if the slope is negative, okay, if the slope is negative, that means you go back to the definition delta Y over delta X. Now, here is negative, okay, the slope is less than 0. If Y increase, if X increase by 1 unit, in other words, X here increase, positive. What about Y?
Decrease.
Y will decrease. Okay?
Decrease.
So Y decrease. So Y decrease mean must be negative value. So that you get M negative. If X decreases by 1 unit, in other words, the X here is negative. The slope must be positive, M must be positive. So what can you say about the Y? Increase. So Y will increase. So for negative slope, the movement of the Y and X will be opposite direction. Okay, I think we know that already. The positive slope, X and Y will move same direction. Okay, X increase, Y increase. X decrease, Y will also decrease. Now for negative slope, they move in the opposite direction. If X increases, Y will decrease by the amount of the M. So let us go back to another, to an example of that one. So say we have M equal to negative 7.8. So now you go back to the definition that we just stated here. All right. If X increases by 1 unit, now what happened to Y? The value of the slope is negative 7.8.
May I try, sir?
Okay, go ahead.
When the X increase by 1 unit, Y will decrease.
So Y will decrease by how much?
Negative 7.8.
But when you say decrease, you don't have to say negative 0.78. because decrease is already going downward. Okay? Okay. So here, if X increases, so now I use arrow up to indicate increases. If X increases by 1 unit, and now you know the slope is negative, it means they will move opposite direction. Y would decrease by how much? By 7.8 units. Or you can say the decrease in Y, okay? The decrease in Y is 7.8 units per unit increase in X. Okay, all right, good. So, you know, that's how you describe the slope. And of course, you can also say, you know, the other way around. If X decreases by 1 unit, the Y will what? Now the Y will increase, huh? Okay? The Y will increase by 7.8 units. So the movement is in opposite direction. Okay. Any question about that? Clear? Okay. So, yeah.
Sir,
Yes.
sir, if I have a point 2, 4, okay, so with the M of negative 7.8, meaning if 2 increase by 1, so from 2 to 3, so the 4 will decrease by negative 70.8. Right, that 2 is X, 4 is Y, the 1 point, the point, and then
you know what?
Is it right?
Okay, you actually, when you look at the slope here, okay, when you look at the slope, when you describe the slope, either the first case here, you know, you got berapa tadi? M equal to 2.1, or you got M equal to the second value, negative 7.8 or any other, you don't worry about the point, okay? Don't worry about the points. Where they are, it doesn't matter. Anywhere, okay? Anywhere, that means any 2 points. If you have any 2 points, what happened to the slope? The slope is 7.8. Now go back to your question. You have y2 minus y1 equal to x2 minus x1, and that is equal to negative 7.8, right? Now, what you were saying is that, what was the value of the point that you give me? x1 apa tadi?
4.2.
4.2. 4.2 means x1, y1.
Yes.
Okay, if x1, y1, 4.2, so you got here 2. That means y1 is 4. So now you have to find y2 and x2 so that the difference will be negative 7.8. Okay? So you find that point. Can you find the point? Okay, so you have to find the point. All right, so the point is quite, you know, you have to find. I cannot find it now. Okay, so I think that relates to your question. So you need to find the second point. Take the difference, the ratio, so that you will get the value negative 7.8, which is the slope. So what you were saying will be like this, okay? You got x, y, 0 here. The slope is negative, okay? So you know the line will be negatively sloped, will be going downward. Now you have a point, 2, 4, okay? 2, 4, 2, 4, 2, 4, 2, 4 be somewhere here. I think my line is not very clear. So I draw another one. You got the point, 2, 4. So 2, 4 will be somewhere here. Okay, I don't have the, I don't put it in scale, all right? So 2, 4 will be somewhere here. That's the point. And you know the slope is negative. Slope negative will be like that. Okay. So now you have to find what is that point. Okay. So that when you take the difference, you get 7, negative 7.8. Okay. But that point is not unique. Because if you take another point somewhere there, the ratio will be also be equal to 7, negative 7.8. So there are many points, y2, x2, for which you will get the same value of m. All right. I think that your question relate to this this thing. Is that right?
All right. Thank you.
Okay. Any other question? Any other comment? Okay. What I would like to do, we are going to look at application. So I have 5 more minutes because we have another class, 11:30. So look at application. I want you to go to example number 2 on page 76. That is on depreciation. So this is one example of a linear function. Or not example, one application. I'm sorry, this should be one application of linear function. Okay, I give you application question, so that I can remember this. Okay, application question on 1.3. I would like you to do a few questions. Do number 49, 50, 51, 53. Okay, so that is application 1.3. Okay, we discussed depreciation, example number 2. I would like you to read, okay? You go home, I want you to read and understand example number 5, which is pricing. So I'll do the depreciation here. All right, we have 5 more minutes. And then you go home, you do the pricing. Okay, so read the question. I mean, not read the question, read the example. Okay, what you are given here, okay, the depreciation. I think you know depreciation, right? If you have taken business course or accounting course or even economics, what is depreciation? I don't want you to define. I just want you just give me the idea. What is the idea of depreciation?
Value decrease.
The value of car, sir.
What? Car.
Car.
Okay, example is a car. What is depreciation relate to the car?
Discounted value.
The value will do what? The value will go down. Okay, so depreciation give you the decrease in value over time. Okay, if the value goes up, you don't call depreciate. If you look at a house, okay, a car, the value depreciate. That means the value of the car will go down or decrease over time. But if you look at the house, normally, does the house depreciate over time?
No.
No. Okay, the asset house.
No.
Or a land, a piece of land that you buy now, in 10 years' time, the value will not depreciate. Actually, the value will depreciate. And I'm sorry, the value will appreciate. All right. So here the question is on the depreciation. That means the decrease in value of a property, okay, value of an asset, okay, over time. So you have the two variables, y as a function of x. So simply, all right, X is the time in period, in units, okay? So period is the unit of the time. It can be year, okay? It can be month, it can be day, or it can be hours or minute. So if you look at that question, what is the time period, the unit? What is it? In that question is month, okay? And then what is the Y? Y is the value, okay? The value of the asset at that particular point in time, okay? At that particular time, at a particular period, okay? Because it relates to the X, which is in period. So the value can be monetary units, dollars, RM, rupiah, or real, pounds, okay? So these are the value. So you look at that example, you have given the general form, okay? You're given the general form. So what I want you to do, I want you to write that in terms of slope intercept. Okay, so slope intercept form, I want you to write that, and then I want you to interpret the slope, describe the slope, what does it mean? And then describe the intercept. There are two intercepts. One is the y-intercept. Secondly, the x-intercept. Okay, so you do that. And of course, you draw the graph. Okay, you draw the graph. I think the graph is already given in the book, so you can refer, but I want you to draw it. Okay, I want you to draw in your own. So you do this example, and also the question that I assign you to do. On Wednesday, we will continue from here, okay? You do this thing, you discuss with your group member how to describe the slope and the intercepts. On Wednesday, first thing, on Wednesday class, we will discuss that. Okay, all right. Okay, I think that's it for today. Any question? Anybody has a question or comment?
Salam, sir.
Yes. Yeah,
I missed the last two classes. Can I get the recorded version of the last two classes?
Where are you?
Ghani.
Yeah, I know. Where are you? Why didn't you?
No, I didn't find anything in Italian. Plus, I didn't know anything about the class. Yeah, I just found the group and everything. I'm so sorry.
So what you do? Okay, yeah. What you do is you find your friend. Okay, you ask your friend. Actually, if you go to the WhatsApp group, okay. I already have the course outline. Okay, uploaded. And I also have the recording of the last week classes, only one class. First class, there was no recording. Okay?
All right, sir.
The first class, you look at the outline. Okay. Second class, I have the recording, which is also in WhatsApp. So you just right, what do you call it?
Ask someone in the group.
You go up, you go up the WhatsApp message, you will find it.
All right.
Now, I want you to find a friend, okay, in the course.
Okay, sure.
You ask him, what have we learned so far? Get the notes.
All right, sir.
Okay.
All right. All right. Thank you.
Okay. So I've given you a question. You have to do the questions. Okay. Do the question so that you will get the understanding. Now, of course, there are also a few more people who missed the Italian. The reason is that I cannot access the Italian, until a few days ago. So that was why I formed the WhatsApp group. With that, okay, with that problem, I understand. There are some people who might miss a few classes because I myself can access Italian. All right. So you didn't join the WhatsApp. So now there are a few people, similar case to you, Ibrahim. So I would like the other people also, go to the WhatsApp group. What is the word when you Move up, move down tu terpanggil apa eh? Lupa dah.
Scroll.
Scroll. Thank you. Scroll up, scroll. Scroll up, scroll down. Okay, scroll down, tak ada benda lah. Scroll up. Okay?
Yes, sir. I
You
understand.
find the cursor line. You find the reference to the recording, the link to the recording of our last week class.
Understood,
Okay.
sir.
All right.
Okay.
Any other thing?
No, sir.
Okay, now I want to ask. Okay, tak apalah. I ask you next time because my time is up. There is another class. Okay, so I will see you again on Wednesday. Assalamualaikum warahmatullahi taala wabarakatuh.
Waalaikumsalam.
Waalaikumsalam.
Thank you, sir.
Thank you, sir.
Thank you so much, sir.
Thank you, sir.
Have a good day, sir.
Thank you, sir.
Thank you, sir.
Everybody have a good day.
Yes, sir.
All
Thank
right.
you, sir.
Thank you.